So let's get cracking. So there are some basic ideas. There are a number of methods. One of the things to understand is that there are a number of methods by which you can solve simultaneous equations. So many, you know, off the top of my head, you can use the elimination method. You can just do it by inspection. So some people can just look at it and they can see it. And as I developed as a math teacher, I became more and more able to see the answers for simultaneous equations. But that's not a method per se. It's an understanding that comes through years of working through these kind of things. But you know, there are other methods. You have the elimination method, a very popular method that is taught to students. You have the substitution method that has its value as you move on to more challenging ones. Then the substitution method becomes more applicable and maybe the more effective way of approaching it. There's using graphs. You can use graphs. There are so many methods, you know. There's so many methods, but students at CSEC level, quite likely, those three methods are the ones that you need to master. I have a very creative one that uses determinants of matrix as well as the matrices method, and I'll share that with you at some point in another video. So I want to get cracking with the video. Just so you know, you can always reach out to us and get involved in the math classes. So let's get going. So I have a pair of simultaneous equations for x and y. And this is a very simple equation. We have 2x plus 3y equals 10 and 2x plus y equals 8. And one of the things that we have to get used to is the terminology. So simultaneous equations, normally we have at least two variables. And as you study math, you'll realize that there are a lot more. You could have equations with 10, 15 variables. The main idea behind simultaneous is that the values of the variables are the same in all of the equations in that system. So this is a system of equations. And in this system, the x in this first equation is the same as the x in the second equation, and likewise the y in the first equation is the same as the y in the second equation. The order of the equations do not matter, but in some ways there tends to be the more complex equation tends to be given first and the least complex and the second, but that's not really anything. It's just the way that one has to be first, one has to be second. The idea is that we want to find the value of x and y, the values for x and the value for y that works in both equations that allows this to be true. So that's really the principle behind simultaneous equations. And, you know, it has so much applications. You know, if you look across the world, there's so many ways in which simultaneous equation is used. In fact, I don't think many things are possible in the world, maybe the majority, if not all, if we didn't know how to solve these type of equations, because a lot of things is trying to find out what is the optimal solution. So let's carry on. So the idea is that so let's get this going and just stop this for a bit. So let's go. So we're going to use the elimination method. So one of the things that I do with equations, I tend to number them. So I say equation 1, equation 2, and that's just to help me as I work through to go back to it. So I write this down, and one of the things you'll see is that I'll share my thinking as well as my working out. And what you see I put on the side sometimes is my thinking, but in this case, I also will write this. I just do this as a habit. And I have a look and I say, since the coefficient of x, here's a term, coefficient, and that's the numerical, well, that's the value that's in front of the unknown. Remember, we're trying to find x and y. So the coefficient of x in this case is 2. The coefficient of x in the second equation is 2. The coefficient of y is 3 in this equation, and the coefficient of y in this one is 1. Just remember that it's not 0, it's 1. So since the coefficient of x in both equations 1 and 2 are equal to each other, we can use the elimination method. And so what we do, we rewrite the equations and we literally perform a subtraction on the equation. We subtract equation 1 from equation 2. And what happens is we get 2x, take away 2x, which makes 0. So this is the elimination method. The idea is to remove one of the variables. And then 3y, take away y, will give you 2y, and 10 minus 8 gives you 2. So we're subtracting all aspects of the equation that can be subtracted, and that will give us this new equation. 2y equals 2. Remember, 2x takes away 2x is 0, so there's no need to write that. 3y take away y is 2y, and 10 take away 8 is 2. So we have this simple linear equation, 2y equals 2, and we know that y is going to be 1. Now, we're not finished, and that's the thing about simultaneous equation. That's just a half of the problem addressed. The second part is to now use the value of y to find the value of x. So we're going to substitute this y equals 1, and we normally just go for the second equation. Remember what I said, in many cases, not all, the second equation is the one that has the simplest setup. And so I normally choose that, but it doesn't really matter which one you use. It just puts it into any one, you should still get the same response. But as you're working through math, you always want to choose the simplest pathway. So you need to look at both equations and say quickly which ones you think will be the easiest to manipulate. But the method, the answer will not matter in the end, meaning the answer, it will not have changed the answer in the end. That's what I mean. The equations won't matter. The answers will be the same if the calculation is done correctly. And so we have 2x plus 1 equals 8, because we've replaced the y here with 1. And then we just keep solving. 2x equals 8 minus 1, 2x equals 7, and x equals 7 over 2. That's another simple equation solved. And there, from here, we can then say x is 7 over 2, y equals 1. This is a habit I have. One of my bad habits is always to state my final answer. My next equation is slightly different. Again, we're asked to solve the pair of simultaneous equations. I write them down. I label them 1 and 2. And then, again, this time, the coefficient of y is the same and not x. So we are going to eliminate y because that's already the same. So we carry on, 5x plus 3y. As I said, the coefficients are the same. What we do next, we're going to do that subtraction again. So 5x take away 2x will leave us with 3x. So 5x take 2x gives you 3x. 3y take away 3y equals 0. And that's why we can subtract. Remember, we're trying to get rid of one of the variables. And then 10 take away 16 is negative 6. So we get 3x equals negative 6. From there, we can divide by 3 to get x equals minus 2. So again, that's a very simple equation, and the solution is x equals minus 2. But do not stop there. We're not finished. There's more to do. So we now need to use this value of x to figure out the value of y. Now, as I said, both equations, any one will work. I tend to use the one with the smaller numbers. It doesn't matter which one you choose, but I tend to just go for equation 2. It's up to you. You can follow me or you can choose whichever pathway you want to take. The answers will not be different if the calculation is correct. So we substitute x equals minus 2 into this equation, the one that I've labeled as equation 2. And you'll see my substitution is just to replace the x with minus 2. And 2 times minus 2 will give you minus 4 plus 3y equals 16. We keep simplifying. Bring the minus 4 to the other side to become plus 4. So 3y is 16 plus 4. 3y is 20, and y is 20 divided by 3. Now, I don't need to simplify this further, for example, to divide it and get 6.666666. It's normally better to keep a more accurate answer unless the question asks for a specific degree of accuracy. In this case, I'll keep my answers as fractions. And so I'll rewrite it. As I said, my bad habit is to state my answers together as a part of a system because they both work together. When x is minus 2, y is 20 over 3. And this is the specific pair of numbers that will make these equations work. Let's carry on. Another example. We have 4x minus 3y, 2x minus 3y, 4x minus 3y is 26, 2x minus 3y equals 16. Again, a lot of students, when they see lots of negative signs or minus signs, they start panicking. But if the coefficients are the same, then it doesn't matter. So as I remember, we label. My steps are the same. The coefficients of y in both equations are the same. It's minus 3 and minus 3. So that doesn't matter. We're just going to have to subtract. If the coefficients are the same, we can subtract without worrying about it. So again, we put that subtraction in. We do 4x take away 2x is 2x. Because the coefficients are the same, when we subtract, we should get 0. 26 take away 16 is 10. So let's rewrite that. So 2x equals 10. Remember, 4x take away 2x is 2x. Minus 3y take away minus 3y is 0 because the coefficients are the same. And 26 take away 16 is 10. X equals 5. Now that we have found x equals 5, we just need to substitute this value into one of the equations. I use equation 2. You could use equation 1, as I said before. The answers will be the same as long as your calculation is correct. So 2 times 5, so I'm substituting 5 here. That keeps the form of the equation, but just this, I'll simplify that. I'm going to bring these to the other side, so I get minus 3y, because I've kept the minus sign here, and bring this across, it becomes a negative. We take that away to give us minus 3y is 6, and then I'll divide by minus 3, and that gives us minus 2. So now I know my two answers. I can write them down. X is 5, and y is minus 2. Remember, as you work through my videos, if you want to stop and work through the questions as I do them, it's fine. You can pause. Remember, you have that control. So that's why I'm not pausing and giving you a chance to work. You can always pause the videos and then work through them. Then check to see if you're on the right track. But I'm just going through it so you can have a nice flow through for the questions. So solve the pair of simultaneous equations for x and y. It's a little bit different, so let's write them down. Now, normally we have the coefficients. We want the first few examples I've done, there's a pair of coefficients which are the same, but in this case, they're not. So when you look at equation 1 and 2, there is no common coefficient. So we now need to think and be a little bit more creative. So what we're going to do is we know that if we multiply the entire equation by the same number, it doesn't change the equation. It's the same equation. It's just written in another form. So what we're going to do, since the coefficient of y in both equation 1 or 2 are not equal to each other, we multiply equation 2 to get equation 3. So we're going to multiply by 3. Now, my choice in this is always to eliminate y. When I have an option, I will choose equation. I choose to eliminate y. And you'll see when I'm starting to work, you'll see why I always choose y when I have an option. And because it allows us to deal with some little tricky situations much easier. So I'll multiply equation 2 by 3. And I'll get 3x plus 3y equals 12, because 3 times x is 3x, 3 times y is 3y, and 3 times 4 is 12. So again, the coefficients are the same, so we can subtract. So we get 4x take away 3x is x, 3y take away 3y, that's 0, and 15 take away 12 is 3. So we get x equals 3. Easy. Done. And the next step is to find y, because we know x. So we're going to substitute x equals 3 into equation 2. And obviously equation 2 is much easier than the other ones to substitute into. So we get 3 plus y equals 4, which means y equals 1. All right. So that's, the working out for it, but that's straightforward. Y equals 1. And then we write our final answer. Again, as I say, you can pause and work through if you want to just give yourself a chance to practice the questions and then check if the working out is what you would have done. But very important here, when we have a choice, I choose to eliminate y. You'll see in all the examples after this that I'm choosing to eliminate y rather than x. And the reason for that is that when I eliminate x, when I choose to eliminate x, it can make the middle a little bit more complicated. And working in the middle is not as straightforward as working at the ends. You'll see why when we do a few of these. Let's look at another one. So 5x plus 2y and 3x minus 2y. Again, I'm looking. Let's put this down. We label our equations 1 and 2. And the coefficients in this case are not the same in terms of value, but they're absolutely the same. As we said, their absolute values are the same, meaning they're 2's. The difference is just the sign. We can still eliminate easily from this. In this case, we'll have to add, because if you add 2y with minus 2y, you get 0. All right. So what we're going to do is rewrite the equations, and we're just going to add in this case. So we do 5x plus 3x will give us 8x. 2y plus negative 2y is 0. 36 plus 20 will give us 56. So we get 8x equal 56. Now that's a beautiful outcome because we have this minus sign. I'm thinking, oh, how do I deal with that? Okay, so we get to x equals 7. And the next stage for us is to substitute this value of x equals 7 into equation 2. So we substitute x equals 7 into equation 2 to get 3 times 7 minus 2y equals 20, or 20. 21 minus 2y equals 20. We keep rearranging. We keep that minus 2y, remember that. And then we divide by minus 2 to get a half. So minus 1 over minus 2. In this case, we can simplify that further because a negative divided by a negative is always a positive. So y is equal to half. And then my bad habit, as I said before, is to substitute, to rewrite the answers. X equals 7 and y equals a half. So I provide a pair of solutions because they do operate in pairs, you see. All right, so carrying on, we have a different situation here. So we solve the pair of simultaneous equations for x and y. We have 5x plus 2y equals 17, 3x minus 5y equals 4. So let's put this down together. And again, if you look at this, we know that there is no pair of coefficients of the variable which are the same. So this will require a little bit of creativity. And so we equal them to 1 and 2. We equate them as equation 1, label them equation 1 and equation 2. And what we're going to have to do, since no coefficients are the same, we have to multiply the equations. We have to make some choices. So both equations will be multiplied to get equation 3 and equation 4. Now, as I said before, when I do have a choice, I tend to go for the y. All right. And so what I'll do is multiply the first equation by 5. And that's going to give me a 10 here. Okay. And to get a similar setup to the one we just did, I'll multiply this one by 2. So when I multiply by 5, I get 5 times 5, which is 25, 5 times 2, which is 10, and 5 times 17, which is 85. And I multiply the second equation by 2. Okay. And I'll call that, as I said, this is equation 3 now. Now I'm going to get equation 4. So I'm going to multiply this by 2, and that will give me 6x minus 10 equals 8. And that's going to be equation 4. Now, because we have the coefficients numerically similar, except for the difference of signs, we know that in this situation, we just need to add. So we can just add the coefficients, add the equations together. So when we add 25x plus 6x, we'll get 31. And if we add 10y with minus 10y, that's a 0. We don't need to write that. That's the reason why we're adding. And 85 plus 8 gives us 93. And that gives us this weird-looking equation, 31x equals 93. But if you divide, you'll find that x is just 3. So we substitute x equals 3 into equation 2. And that's going to give us 9 minus 5y equals 4. Because when we put that 3 in, that's what we're going to get here. We can keep rearranging, and then eventually we'll get minus 5y equals minus 5. As I said, you can pause to make sure that you're following the steps. I'm not skipping any step at all, so you can easily follow through. And then y equals minus 5 divided by minus 5, which gives us 1. All right, again, my bad habit. Replace rewriting the solution, the pair of solutions. All right, let's carry on. Let's look at another example. 5x plus 3y equals 17. 2x plus 5y equals 3. Again, we do not have any pair of coefficients which are the same for any variable. So we can label them 1 and 2 as usual. We're going to have to multiply the equations to be able to get equation 3 and 4. As usual, as I said, whenever I have a choice, I'll always eliminate y. So I'm going to multiply this equation by 5 to get 25x plus 15y equals 85. And I'm going to multiply the second equation by 3 to get 6x plus 15y equals 9. Again, I'm going for y. But in this case, we have the same coefficient, 15 and 15 in front of y, so we can take away. And that's, as I said, equation 4. So we take away 25, take away 6 is 19, and 85 take away 9 is going to give us 76. So we have a nice equation here. Again, some weird numbers, but if you divide, you'll find that x is just 4. All right. We now know the value of x. We use that value to find the value of y. Substitute. Again, I always do the second equation. It doesn't matter. The answer should be the same irrespective of the equation chosen, but I tend to just go for the second equation. And so I substitute, simplify, continue to simplify, continue to rearrange and solve. And then I'm going to divide by 5 to get -1. My final step is just to substitute, to rewrite my solutions as a pair. So x equals 4 and y is -1. So I hope that that was useful for you. I haven't set any homework, but the idea is that you should be able to be able to work through the problems that you have here, your simultaneous equations, and be able to work through the examples that I use so that you can get a better understanding of how simultaneous equations work. There are other types of simultaneous equations. There are many that require different type of approaches. There are simultaneous equations that can lead to quadratic equations. There are other methods, as I said. You can use graphs, you can use substitution, you can use matrices. There are many, many methods. This is not about all the methods. It's just a method that normally is used in the first part of most exam papers, and most students are expected to use this method with some level of accuracy so that they can be effective problem solvers. So I hope you enjoyed that video. This one is another one that was delivered live, and now I've just created a video to match that lesson because I've heard some students say they missed the lessons. Some students are saying that they wish that they could watch the videos again or share them with their friends. So that's what we're doing, just sharing those videos and giving you a chance to work through these problems again. And if you have any issue, any questions you have in mind that you think, perhaps you could, you're thinking, oh, I wish I could have this, then please let me know, and I'll let you in. So, and I'll add that. So yeah, so hopefully that was useful. So see you, as I said before, math clinics are held on Sunday at 11 a.m. Jamaica time. That's 11 a.m. Eastern time. The first part of the session is to work through problems that students bring. So we kind of have a quick triaging. So we triage, we find out what the problems are, we work out some problems, we may have a chat about math as well. And then the next part of it is to introduce a topic for the day, which normally begins about half an hour in. And then we have some live worked questions where students participate, and Mr. Fullerton will do his stuff, making you feel and enjoy your math. So looking forward to seeing you at those sessions. And this is the simultaneous equation session. And this is Dr. Barker signing out. Thank you very much. And I hope that was useful to you.